Hello everyone, welcome to Brain Blitz Audios. Today in this episode of Cbse board exam, we'll be continuing our discussion of the sample paper for the year 2021 published by Cbse. This is the fourth video on the series, and today we'll be dealing with section 3. In section 3, you'll have questions marked for 2 marks. So basically, when you answer a question correctly in the proper format, you'll get 2 marks. Now, in these kinds of questions, some steps are more important than others. And so today we'll be looking at which of these steps are important while answering your question. Let's look at our first question, which in this case is question 19. Express tan inverse of cos x by 1 minus sin x minus 3 pi by 2 less than x less than pi by 2 in the simplest form. This is for 2 marks. As in any question, the first thing you need to do is to write out this expression. Tan inverse of cos x divided by 1 minus sin x. Now, what would you do here is you convert cos theta to sine of pi by 2 minus theta, and sine theta to pi by 2 minus, cos of pi by 2 minus theta. Basically, you get the equation tan inverse of sine pi by 2 minus x divided by 1 minus cos pi by 2 minus x. So this is what you get. Next, what we're going to do is we're going to convert sine 2 theta to 2 sine theta cos theta. And we'll also be converting 1 minus cos 2 theta to 2 sine square theta. Essentially, what we're doing is we're making 2 theta as pi by 2 minus x. Therefore, theta is equal to half of pi by 2 minus x, which is pi by 4 minus x by 2. So therefore, you'll get tan inverse of 2 sine pi by 4 minus x by 2 cos pi by 4 minus x by 2 divided by 2 sine square pi by 4 minus x by 2. Both of these steps earns you a half mark. So half marks are earned when you write both of these steps while reducing the equation. Next, what happens is that you need to convert this to cot and eventually to tan form. So what I'm going to do is I'm going to cut out 2, and I'm going to cut out the sign in the numerator and one of the sine functions in the denominator. So you will get tan inverse of cos pi by 4 minus x by 2 the whole divided by sine pi by 4 minus x by 2. So cos theta divided by sine theta will give you cot theta. So tan inverse of cot pi by 4 minus x by 2. This step and the step before it together earns you 1 mark. So if you write this and you write that, tan inverse of cot pi by 4 minus x by 2, you'll get 1 mark for that question. Now, cot is eventually converted to tan. So tan inverse of tan pi by 2 minus pi by 4 minus x by 2. Again, you have to be careful with brackets. So if you write the cot and the tan terms together, so you're basically converting the inside to a tan function. So that gives you 1 mark. Next, you can cancel out the tan inverse and tan functions. So you'll get pi by 2 minus pi by 4 plus x by 2. We are distributing the minus across the bracket. Pi by 2 minus pi by 4 gives you pi by 4 plus x by 2. that is your final answer, and writing that will earn you a half mark also. So a half mark for converting it to sine by cos, converting it into sine and cos form, and using the two identities. Sine 2 theta is 2 sine theta cos theta. 1 minus cos 2 theta is 2 sine square theta. 1 mark is given when you write the cot the inside function in terms of cot and tan, and a half mark is given for writing the final answer. Next is question number 20. If A is a square matrix of order 3 such that A square equals 2A, you need to find the value of the determinant of A. So, to find the determinant of A, we're going to use A square equals 2A. A square equals 2A. And what we can do is we can apply determinant on both sides. So determinant of A square is equal to determinant of 2A. A square can always be written as determinant of A times A, and the right hand side is determinant of 2A. Now what we're going to do is we're going to write the left hand side in the form of determinant AB equals determinant of A times determinant of B, and the right hand side will be determinant of KA equals K raised to N times determinant of A. So in this case, since the order N equals 3, so you will get determinant of A times determinant of A on the left hand side, and on the right hand side you'll get 2 cubed times determinant of A, which is equal to 8 times the determinant of A. This step gives you a half mark. So this is one of the most important steps here. Next, we're going to pull 8 times determinant of A to the left hand side. So that means determinant of A times determinant of A minus 8 times determinant of A equals 0. We'll take determinant of A as common, and determinant of A minus 8 in the bracket, that gives you 0. This step gives you 1 mark. And from here you have two scenarios. Scenario 1 is when determinant of A is equal to 0, and scenario 2 is when determinant of A minus 8 equals 0. In that case, determinant of A is equal to 8. So we have two answers. Determinant of A is equal to 0, or determinant of A is equal to 8. This final step will also give you a half mark. Now let's look at the second option given in the 20th question. So this is the OR question. If A is 3, 1, minus 1, 2, show that A square minus 5A plus 7I equals 0. And hence you need to find A inverse. Now, we have the matrix A equals 3, 1, minus 1, 2, and we need to find out that we need to show that A square minus 5A plus 7I equals 0. So what are we going to do is we're going to find the values of A square, 5A, and 7I. A square, we can write it as A times A, that is 3, 1, minus 1, 2, times 3, 1, minus 1, 2. The reason why I wrote it as A times A is because we're doing matrix multiplication, so therefore writing a square on top of this is not the correct manner. 3 times 3 is 9, plus 1 times minus 1, that is minus 1. 3 times 1 is 3, 1 times 2 is 2, so 3 plus 2. Then we have minus 3 minus 2, then minus 1 plus 4. So these are the 4 terms for the value of A square. The value of A square now becomes the matrix 8, 5, minus 5, and 3. This is A square. To find 5A, what we're going to do is we're going to multiply 5 to the matrix 3, 1, minus 1, 2. That gives you 15, 5, minus 5, and 10. You can multiply a constant to all the terms in the matrix, to all the rows and all the columns. And to find 7i, it's pretty easy. I is the identity matrix. It will be multiplying 7 to 1, 0, 0, 1. That will be 7, 0, 0, 7. The matrix 7, 0, 0, 7 is 7i. Now, to our equation. A squared minus 5a plus 7i is equal to, we're not going to equate it to 0. We're going to find out whether it's equal to 0 or not. So we'll be putting the values of a squared, 5a, and 7i. So a squared is 8, 5, minus 5, and 3. 5a is 15, 5, minus 5, and 10. Plus, the identity matrix is 7, 0, 0, 7. So we're subtracting the first two matrices using BODMAS, so subtraction comes first. 8 minus 15 is minus 7, 5 minus 5 is 0, minus 5 plus 5 is 0, and 3 minus 10 is minus 7. So minus 7, 0, 0 minus 7 is the result. Now we add that to 7, 0, 0, 7, and from here onwards, it's obvious that the function is that the matrix is a 0 matrix. So a squared minus 5a plus 7i is equal to 0. Now this whole step earns you 1 mark. So we need to prove that a squared minus 5a plus 7i equals 0, and that proof gives you 1 mark. But we're not done with this question yet. We need to find the value of a inverse. So in order to find the value of a inverse, a squared minus 5a plus 7i equals 0, the next thing we're going to do is we're going to pre-multiply a inverse on both sides. On the right hand side, if you multiply anything by 0, you still get 0, so that is not a problem. But on the left hand side, since we use the term pre-multiply, that means a inverse always comes first in the matrices. A inverse times a minus 5 times a inverse times a plus 7 times a inverse times I. That is equal to 0. A inverse a, so the multiplication of a and its inverse gives you I. That's the same case here. So you have a minus 5i plus 7a inverse equals 0. That means 7a inverse is equal to 5i minus a. We can just calculate it as 5005 minus 3, 1, minus 1, and 2. 5 minus 3 gives you 2. 0 minus 1 gives you minus 1. 0 plus 1 gives you 1. And 5 minus 2 gives you 3. So that is the value of 7a inverse. The value of a inverse is 1 by 7 times 2 minus 1, 1, and 3. That means it is 2 by 7 minus 1 by 7, 1 by 7, 3 by 7. And so therefore, the value of a inverse is this matrix. And for writing this step alone, you get 1 mark. Now to question 21. In question 21, you have to find the value or values of k so that the following function is continuous at x equals 0. So over here, the condition is given that the function is continuous at x equals 0. F of x is 1 minus cos kx divided by x sine x if x is less than 0, 1 by 2 if x is equal to 0. Now, let's make sense of the given condition. Following function is continuous at x equals 0. Now, for f of x, the function, to be continuous, what you have to do is you have to equate limit x tends to 0 f of x is f of 0. So limit x tends to 0 f of x, limit x tends to a f of x is equal to f of a for fx to be continuous. If this condition is not met, then the function will not be continuous at that point. So over here we need to find out the continuity, you need to find out the value of k so that there is continuity for this function. So limit x tends to 0 f of x over here is limit x tends to 0, and the term that is not equal to 0 is 1 minus cos kx divided by x sine x. Again, we use the formula 1 minus cos 2 theta is equal to 2 sine square theta. So this becomes limit x tends to 0, 2 sine square kx divided by x sine x. Now note that sine square kx is the same as sine kx the whole square. So both are the same. This is important when we're moving further along this question. So far, no marks are given. So these are not the important steps yet. The important steps are still coming. Now what we do is we're going to divide the numerator and the denominator by x squared. So therefore that is limit x tends to 0 to sine square kx by 2 divided by x squared, the whole divided by x sine x divided by x squared. So these will cancel out anyways, but we're putting them because of a special reason. So now the interesting bit is in the numerator we're going to multiply and divide by k by 2 the whole square. So let's do it. Limit x tends to 0 to sine square kx by 2 divided by kx by 2 the whole square times k by 2 the whole square. So k by 2 the whole square multiplies with x squared in the denominator to form kx by 2 the whole square. And then the denominator, in the denominator, the x cancels out with x squared, so you get sine x divided by x. So this is the step that gives you 1.5 marks. So this step is the most important step here in the question. Now what we essentially did is that we converted this equation to the form of two. So the equation now becomes 2k squared by 4. So k squared by 2 multiplies with 2, so that happens. And then we have sine kx by 2 the whole square divided by kx by 2 the whole square. And then in the denominator we have sine x divided by x. Now why is this form very important? Because now we can use this formula, limit x tends to limit a tends to 0, sine a divided by a is equal to 1. So if you have this form, you can convert it to 1. So over here, sine kx by 2 the whole square divided by kx by 2 the whole square gives you 1. Sine x by x also gives you 1. So that's why these two steps gives you 1.5 marks. So now we get 2k squared by 4 times 1 divided by 1. So this is the value of limit x tends to 0 f of x. Now since f of x is continuous, we will now apply that property. So limit x tends to 0 f of x is equal to f of 0. So therefore 2k squared divided by 4 is equal to the value of the function at x equals 0 is half. So 2k squared by 4 equals 1 by 2. 2 and 4 gets cancelled, so that becomes k squared by 2 equals 1 by 2. The denominators cancel each other out, so you have k squared equals 1. That means k is equal to plus or minus 1. So you have two values, k is equal to 1 or k is equal to minus 1. This step earns you a half mark. So in this question, the most important step is to make it to the form limit a tends to 0 sine a by a equals 1. When you can convert it to that form, then you have solved the entire question. You just have to substitute it as 1 and then find out whether it's continuous or not, which we did. So since it's continuous, we found the value of k, which is 1 or minus 1. Now let's look at the final question for this episode since the video is going long. So this is question number 22. We need to find the equation of the normal to the curve y is equal to x plus 1 by x, x greater than 0, such that it's perpendicular to the line 3x minus 4y equals 7. So over here, normal is perpendicular to the given line. But first things first, the equation of the curve is y equals x plus 1 by x. So when y equals x plus 1 by x, we just differentiate it. So dy by dx becomes d by dx of x plus 1 by x. d by dx of x is 1. d by dx of 1 by x is minus 1 by x squared. So dy by dx is 1 minus 1 by x squared. Well, we can stop there. Now we can go to 3x minus 4y equals 7. So we'll now convert this to 4y equals 3x minus 7. And y now becomes 3 by 4x minus 7. Now this is of the form y equals mx plus c. So therefore, m, that is the slope, is equal to 3 by 4. Now in the question, the normal is perpendicular to the line. That means the tangent of the curve is parallel to the line. Since the normal is perpendicular to the tangent as well, that means the tangent has to be perpendicular to the line given. And when the tangent is parallel to the line, that means the slope is equal. So when the slope is equal, you have 1 minus 1 by x squared equals 3 by 4. That means 1 by x squared equals 1 minus 3 by 4. That is equal to 1 by 4. X squared equals 4. And x here equals to 2. Now usually in a root you have positive and negative values, but over here x is greater than 0, so therefore the value of x has to be plus 2. Now for all of this, to find the slope, to find x, you get 1 mark. And after finding out x, you can find y pretty easily. That is x plus 1 by x, so 2 plus 1 by 2. That is 4 plus 1 by 2, which is equal to 5 by 2. Now, we have found the slope of the tangent, but we need to find the equation of the normal. The first thing is we need to find the slope of the normal. The slope of the normal is equal to minus 1 by slope of tangent, which is equal to minus 1 by 3 by 4. That is equal to minus 4 by 3. This is the slope of the normal. And now we need to use the equation of the normal. The general equation is y minus y1 is equal to minus 1 by m times x minus x1. Minus 1 by m is the slope of the normal. So we have y minus 5 by 2 is equal to minus 4 by 3 times x minus 2. We'll convert the left-hand side to 2y minus 5. And so you can multiply the right-hand side by 2 as well. So that means minus 8 by 3 times x minus 2. Now we need to remove this fraction, so we multiply by 3 on all sides. So it becomes 6y minus 15 equals minus 8 times x minus 2. Then we can write 6y minus 15 is equal to minus 8x plus 16, because 2 times 8 is 16. Then we rearrange the terms. You have 8x plus 6y equals 16 plus 15. That means 8x plus 6y is equal to 31. So 8x plus 6y equals 31 is the final equation. And from the equation of the normal till you find the actual equation, you get 1 mark. So this whole step gives you 1 mark, and finding out x gives you another mark, so 2 marks. Now that concludes this video on Cbse board exam. If you want to watch our earlier videos, don't forget to hit the link in the description down below, which guides you to our playlist. For more of our useful and interesting content, don't forget to subscribe to. So until the next webisode, take care, stay safe, bye-bye for now.